Here are two new Fantom motors for touring car, mainly for touring car and 1/12 scale type racing. There's two versions. These are 13.5 turns as an M and an RS. The M is for normal touring cars, buggies running with 2S batteries. The RS is supposed to be for 1S lipo batteries, such as in 12 scales, etc. And so I'm going to look through the spec and then do a test on them and see what the differences are. So we've got the specification here as put out by Fantom, and there's lots of information. It talks about developed in the US over 6 months of R&D, and talks about stators, rotors, and the most important statement, and in fact the best part of the whole motor, is the stators are made from premium Kawasaki steel. Now I've always said that the laminations in the motor are very, very important. In fact, laminations in any piece of equipment that uses wire wrap round laminations, such as transformers and other forms of transferring magnetic power. The laminations are the most important part for efficiency and transfer of magnetic field, and so the better the laminations, the better it's going to be. I would say up to now manufacturers probably try to save on the lamination costs, but by going to the best steel they can find, you're going to get the best performance. Anyway, countless hours of track testing has resulted in two different designs to cover motors, not just giving different stack heights, completely different designs. Stack heights, I don't know whether they mean the length or actually the thickness in the other direction. Anyway, Type M is recommended for buggies, touring cars, RS 1/12 scale 1S. Now let's go through the individual specs. Rotors precision balance using premium grade neodymium type magnets for extreme horsepower, superior fade resistance. I think all the top manufacturers now use this quality of magnet in the rotors, so there's nothing special there. Laser engraved. Yeah, a lot of manufacturers are putting laser engraving with their logo and perhaps some other info. Now, more power to the people, as sung by John Lennon. Specs and features. Designed in the USA, meets or BRCA Roif specs. Built 12.5mm high torque rotor, which is pretty normal for most of the top manufacturers now go to the max allowed on spec type motors. Precision balanced rotor, well, everyone will have a precision balanced rotor. Premium grade neodymium magnets, as I said before. Yeah, that is the best, and all the top people who use that. It will give you best horsepower and less fade due to temperature. Premium grade steel stator plates, we've already spoken about that. Maximum size allowed. I'm not sure what they mean by maximum size allowed, what they're talking about, but it says 99.9% pure copper high temp wire. Maybe they mean the maximum gauge of wire. Yeah, all the top manufacturers use that. Only the cheaper motors use thinner gauge to make it easier to wind and quicker to wind, so you get messy windings. If you use the thickest gauge allowed, you have to be very careful as you wind it, or it won't all go round. High temperature wire, yes, of course. The enamel has to resist high temps and not melt, so they don't burn out like in the olden days when they burn out very easily. High power, low resistance, thick copper gold plate, solder lugs and collector ring. Yeah, you want the best connections you can from the wire to where you solder on. So good thick plates are good. Nothing unusual there. CNC machine billet, aluminium end plates, precision bearing alignment. Yeah, that's important. As are the fitting of the bearings. A lot of motors, the bearings are much too tight or too loose, where they're fitted, which gives some problems in motors, but not the top ones. Integrated can end plate venting. Yeah, I think all the top people are onto maximum cooling slots and vents, etc. A few of the older designs are a bit enclosed, which makes them a bit hot. Sensorless operation, yeah, it's nothing unusual. Inspection window inside the can. That's to enable you to measure the lamination maximum or minimum height or width. So you've got to have that anyway. Infinite adjustable timing, well, that's good. That means you can adjust it to up to 60 degrees or up and down. Some of the older designs wouldn't allow you to go to max. High RPM precision bearings, well, bearings aren't normally a problem these days. Unless you get dirt in them, they all seem to cope. I've never known a bearing cause a problem in the motor unless it's being damaged, or in some of the cheaper designs where it's too tight, where it's been hammered into the case and it's distorted the bearing and caused it to be lumpy. That's not going to be a problem in these top quality motors. There's a sensor cable included. So looks like a pretty good motor. They've thought of everything. The steel stator plates or laminations are the good selling point for this motor, and probably what's going to give it its great performance. Other motors all meet these sort of specs, so they've thought about everything. Hopefully the quality control when it's made is meeting the requirements, and so we're going to test the motor and see how good it is. Here are the two motors. You've got the Type M and the Type RS marked on them, 13.5, 13.5. They look very similar at first. Through this little window here, you can see the stack length from one end to the other, and the same on this one. It's probably not clear here, but I'll put initially it doesn't seem to be much difference. I'll put a gauge on that in a second, but first of all let's weigh them. It's got some scales here. Turn it on. So we've got the Type M, 164 grams. The Type RS, 158 grams. So there is a difference, the RS being lighter by 6 grams. Out the box, both motors are set exactly to 30 degrees marked on their end bells. So I'm going to test them first as they come and compare, then optimize the settings and see if there's any difference in the kV or RPM or the power or anything like that. Starting with the 13.5M as it came, showing a 28 degree average, and the spread see 26, 27, 30, which is not too bad for a sensor board. That's 4 degrees from max to min. I'm just going to do the kV next. Okay, the kV is very good reading, over 3100, only at 1.9 amps, and there's the revs. So it's looking like this is going to be quite a powerful motor when we set this around about 6 amps. The RS as supplied, much higher revs and much higher kV, 3244, and the revs are 24007, but the amps is slightly higher too. So it's all about optimizing to see how they perform at the optimum point. I've set the RS version to an optimum 6 amps, which as you can see is giving just over 4000 kV, nearly 29,000 RPM. So I'm just going to check the timing, then we'll do the next one. The timing of the RS1 when set to 6 amps is 49 degrees average and a 48, 50, 50. So the sensor boards actually got closer together at the optimum point. Timing on the M bell when adjusted to the 6 amps, you can't probably see it, it's 52 degrees on the markings on there. Just set the M to exactly 6 amps. It's giving you 3962 kV and the 28531. The timing on the M version when set to 6 amps is average of 48, and it's got a spread of 47, 47, 51, which isn't quite as close as on the RS version, and may actually be the reason for slight variation in the final results, but still pretty close. The timing on the M bell after adjusting it to 6 amps on the M version, you probably can't see it exactly, but it's 53 degrees or almost identical position as on the RS one. Next I'm going to check this 24K Revtech 13.5 turn motor. We know these are really good, and I'm going to check it out and compare it to the Fantom and see how they compare, because up to now the 24Ks have been the motor that has been beating all the others. I decided to re-shim this motor. It was rock solid, so there was no end play, and you need a tiny bit. And also I find that when they make them, they put loads of shims on this end, the girl whoever assembles it, which moves the rotor a long way away from the sensor board, which can also give less than the best result. So I've re-shimmed the rotor as close to the sensor board as I can, and now got a little bit of end play, and I'm going to retest it, see if it's improved the performance. After re-shimming and moving the rotor nearer the sensor board, it hasn't really made much difference. A small increase in RPM and a small increase in kV, which, okay, a small increase is better than nothing. And I'll just recheck the timing now. It says 42 degrees. 43, 43, 39. Focus is past the 60 degree mark. So the sensors on these boards on these are way out. I've taken the rotor out of the Fantom. It says Fantom on it, 12.5 millimeter. It's got engraving on it. 8 high torque it says. So let's just test it. 1452 the other way. So it's slightly stronger than the other motor, but other rotor from the Revtech 1438, let's say, and 1452. It's quite well matched, so well made, and the size, well, it says on it it's 12.45. Just check that if we can measure, but it says 12.43. So the rotor strengths are very similar between the motors as well, and the diameters are the same. The heavy duty plates here. The wires are soldered just in the holes as usual. They come up and into the holes in the plate and then soldered. They should really be bent over, opened out and pressed onto the metal for best contact. Solder is not the best conductor of electricity, and it's just around the wires, so the current has to flow through the solder onto the plate. But it's better on the front plates. They can always bend the wires around it. There's more room to bend the wires over, and you get a much better contact. But here, because of the shortness of the motor, they don't allow any room for the wires to poke out and bend over, which would increase the length of the motor by 1 millimeter or so. But these are nicely staked onto the fiberglass former to stop them flapping around. On some motors these flap around. I know the Revtech ones can come loose, and this one especially can move around. Even though the wires are still connected, it's not great. So measuring the stack length is not very easy. Stack length of the RS is about 19 point. Okay, stack length of the M 19.65. It's virtually identical, really, considering the tolerances. The M stator weight 110 grams. The RS stator weight 104 grams, so that's where the difference is between the weight of the two stators. This is the sensor board out of the Fantom. It's pretty standard design. It's exactly like we see on a lot of other motors, including the Revtech Trinities. It's just got the three sensors on the top. And the accuracy of them, how they're placed, will give the accuracy of how closely they match on the sensor timing. Okay, we'll check the stator winding resistance, see if there's any difference. This is the M. I've got this very accurate low resistance meter. 0.028 on that coil. Check another coil. 0.027. Check the third coil. 0.027, about normal. That's the M1. Let's try this BRS one. .27, 0.28. 27 and 27, identical on resistance reading, so the stator winding length must be the same. I'll try and do the inductance next. The Type M inductance, 31 microhenries on this pole, and it's about 27 and 28 I measured on the other poles when I turn it. So I'll just check the RS one. The RS inductance, I measured it, it's 23, 24 and about 26 microhenries, so it's slightly less inductance than the M version, which shows there is a very slight difference in the construction. 24K 30.5 turn inductance, highest reading is 27. I also got a 25 when I turn this. That one's reading about the same as the Fantom RS. So after testing these two motors, taking them apart, measuring everything, how have they stacked up? Are there any difference between the M type and the RS type? Well, doing the tests I can, based on lots of motors I've tested, which give good results from the testing to the track. I've got some figures now and we'll just go through them. So this is the result of all the testing I've done. I've got the Fantom, the M and the RS. and I've measured the time in kV RPM, the amps. I've checked the resistance and the inductance of the windings, checked the stator lengths, checked the rotor, the actual size, the Gauss readings, weighed the stators, weighed the whole motor. So first of all, let's look at the weight. 165 grams, 158 grams. So the RS or 1S or whatever you want to call it is lighter by about 6 to 7 grams. And when I took the stators out and weighed them, the stator was actually 6 grams lighter. And I think that's where all the weight difference is. And the stator, because the rotors have got the same number engraved on it, FAN 9591, and they measure exactly the same size. And the Gauss readings, I did take a Gauss reading on that one, I haven't written it down, are virtually the same anyway, just to be a small variation in manufacturing. These two readings are the plus and the minus, so if you measure the pole one side and the other, they should be identical, but due to small variations in manufacture, you probably get a slight variation. As long as it's not too wide, that's okay. Stator length, very difficult to measure because it varies slightly the way they've been squashed together. You get, depending where you put the calipers, you get a small variation, but I think they're identical. There's no difference in length, and I didn't count all the laminations, but they look exactly the same. They didn't look one less than the other, and I would say it's about, they were the same, measured 19.6 and 19.56, but it depends where I got the calipers on the laminations, so I think that's the same. Now, resistance 0.027 on my very accurate resistance meter, 0.027 on both. As a comparison, on a Revtech 24K 13.5, that's also 0.027. So I would say there's nothing special about the wire. It's not shorter than anyone else's, but it's just as good as they can get it. I did measure the inductance, and there is a difference on the inductance. The RS version's got slightly less inductance, which implies a slightly less metal in the stator or in the laminations. Must be fractionally smaller in size in one way or another. Not much. If I measure all three poles, three windings, there's a slight variation, one slightly higher on the RS, this one 27, 28, 31 microhenries, this 23, 24, 27. As a comparison, on the Revtech 24K, they were 25, 25, 27, so very sort of halfway between the two. Now, I did do all the tests on the time in kV RPM. Out of the box, I tested them first with the M and the RS, both having a time in actually measured on my machine as average of 28.29. A slight spread on the sensors. You really want the sensors to be identical, but again, I've seen the design of the sensor board they used before on other makes and motors. No one seems to be able to get the sensor spot on using this design of sensor board. It's fairly close, 26, 27, 30 on that one, and 26, 28, 32 on the RS. Timing as supplied, kVs measured as supplied already. The RS one is slightly up, revs are slightly up, but current's slightly up as well, so it's not really an accurate comparison till you set the currents the same. So I then tuned them accurately to both at 6.0 amps on the tester, measured the N-bell time in, 48 on the M, so it's 47, 47, 51, quite close, could be closer. 3962 kV, 28531. Now on the RS, timing's closer, 48, 50, 50. Now that will give a slight increase in performance anyway. I mean, if it was 50, 50, 50, that'd be your maximum performance. So the kV slightly up, rev slightly up. but doing the calculation between the two, that is a 1% increase. Does that make any difference? Well, if you look at a race, for instance, which is 5 minutes, 300 seconds long, if you could increase your performance by 1%, you would gain 3 seconds, which is quite a lot at the top level. But that does not mean that a 1% increase on the motor is going to give you that performance on the track. I don't think you'd even notice it. And in fact, a small variation on the M bell will swap this one way or the other. I think that's within measuring tolerances or setup tolerances on my gauge and measuring, etc. But it is higher on the RS one. That's all I can say, really. There's no massive step between M and RS. The only reason I would use this RS1 in my car is it's lighter. It's worth saving 6 grams. I can't see any other performance gain, but someone else can tell me there's a huge performance gain in their car, that they probably haven't used one then the other and compared it. That's just comparing it against their friends and saying how much better it is. So, conclusion, as I've done a previous video comparing the 1S and 2S on other motors, I can't really notice any difference in the results to say that the 1S, or in this case the RS, is going to be a fantastic increase in performance over the others, no matter whether you're using a 2S or 1S battery. So that's the results for the testing, and you can go away and draw your own conclusions from all that.